thought I was looking over here. I'm trying to understand.
My apologies to the online people again for all this connecting stuff.
No.
We're not there yet.
I used. So what number was it? Oh, I was doing a lot. I didn't do number 2. But yeah,
Oh, I have to pass out this attendance stuff. Again, sorry to the online people.
I wondered you would do that. You would make
Well, let's do it one more time. I think we're about to get there. Aha. We are. And there are my little pencils up there at the top. Praise the Lord. Only need one more thing out of here. In case I start coughing, my little bottle of water. Let's pray. Father, thank you for this time we have together. I ask your blessing on these students as we work through this new chapter. Help them to take good notes so they'll do well on the test, and help them to understand these concepts about numeration. In Jesus' name we pray. Amen. Okay. Chapter 4, Numeration Systems, page 190. In problems 1 through 6, use the symbols given in table 4.2 and 4.3 to write each number in Egyptian notation. What does number 2 say? 54. Isn't that the way you read that? 54. Now, see, I have Egyptian numerals up here across the top of the screen. You'll want to put those Egyptian numerals on your notepad and keep them handy. And how would I say 50? 5 of those little 10 symbols, and those little symbols are called heel bones. 1, 2, 3, 4, 5. That takes care of the 50. Now, how do I say the 4? 4 of those little strokes. They have names for them back there if you want to learn the names. Doesn't matter if you don't know them as long as you know how to use the symbols. 1, 2, 3, 4. There you go. Write each number in Egyptian notation. There's 54 in Egyptian. Number 4, 1,247. I might need to erase this one and move it over. 1,247. How am I going to say 1,000? See that little lotus flower? Is that what that is? Yeah, it's like one of these. Let's see. And then up, and then out, and another one of those. How cute is that? There's 1,000. Now, how am I going to say 200? 2 of those little backward things. 1,200. Now, how am I going to say 47? 4 heel bones. And then what? 7. And you can stack them up like that if you want to. Sometimes you see them stacked up, sometimes you see them all in the line. It's just a matter of, it's all right there together. So there's 1,247 in Egyptian notation. Do you feel like you've just taken a tourist trip to Egypt? You're standing around a pyramid and writing Egyptian notation? Just close your eyes and picture yourself somewhere. Okay, enough of that. Let's do number 6. 11,209. Oh, there's only one 0 in there. Yeah, because it's 209. Okay. Lighten up. So what do I put here for 11,000? I don't. I have 10,000, which is what? A pointy finger. And that leaves me with 1,209. And what do I do with that? Draw a lotus flower. And that takes care of 1,000. So now I'm down to 209. Everybody follow how I'm thinking through this?
Why is this guy pointing at the flower though?
Why am I putting a flower there? Okay, the pointy finger was 10,000. So if I take 10,000 from 11,209, I'm left with 1,209. Is that your question?
No.
What's your question?
I'm just being an idiot.
Just having a little fun with Egyptian numeration? Hey, might as well have fun with it rather than get mad and go TIS. This is stupid. Okay, so now we've got 1,000. So now we're left with 209. So we go to hundreds, make 2 of those. And then 9. Oh, we can't do a 10, so we go. There you go. Well, that's enough of that. Number 8, translate each Egyptian numeral into decimal. Okay, so what's the lotus flower? 1,000. What do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9 what? 900. Everybody see what I'm doing? And then 1, 2, 3, 4. So what would that be? 1,904. Everybody see what's happening? Good. Are you going to have in your notes those numerals and what they mean? Because you're not going to remember it in your head. So you put it in your notes and just keep it with you. Number 10. 1, 2, 3 what? 4. I'm sorry. 4 what? 4 heel bones. That would be, what's a heel bone worth? 10. So that's 10, 20, 30, so that's 40. 1, 2, 3, 4, 5. That's 5, so it's 45. Number 14. Add 148 and 45. You go, that's easy enough. 8 and 5 is 13. Carry the 1. 4 and 4 8 is 9. That's 193. Yeah, but they want you to do it in Egyptian notation. So you have, what is that again? That scroll is 100. And see this? 10, 20, 30, 40, 50, 60, 70, 80. So we have 100 for the scroll, plus 80, plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Or let's do it this way. Let's go 1, 2, 3, 4, 5, 6, 7, 8. 8 and 2 would make another one of these heel bones, right? And then 3 left over. And a heel bone is worth how much? 10. and then 3. So we just add all that together. 180 and 10 would be 193. And I know I got it right because of what I've written over here. So are we on our way?
Do you have to write out the whole equation in the numerals, or can you just write the answer in the numerals?
Yeah, you're saying, could I just take 193 and then put the answer down?
Yeah.
What did they ask you to do? Write it in Egyptian notation and perform the indicated operation. So they want you to mess with that Egyptian stuff just so you kind of get in your head how you would do it in Egyptian.
Okay.
Because there might be one of those on the test, so you want to kind of practice it. Number 18. Use the Egyptian method of successive duplications to find the product. What page is that on? That's on page 185. Now, my problem is 18. 18 says, whoa, get this thing back down there. Where'd it go? 18 is 25 times 15. All right? Oh, let's turn it around. Since the way I have it written here, that would be the same as 15 times 25, wouldn't it? I can write it either way. And since I've done it this way on the scroll here, then I'll just turn it around to do it. If we were doing it the other way, then you would just have 1 times 15, and then 2 times 15, and then 4 times 15, and 8 times 15. That's why it's called successive duplications, successive doubling. And probably the best way to do this one is put down successive, multiply with successive duplications, and then have a picture of what you do, a little sample problem, so you know what you're doing every time. Because here's what you're doing. 15 times 25, I go 1 times 25 is 25. 2 times 25 is 50. 4 times 25, if I'm doubling, 1, 2, 4, 8, 16, then 4 times 25 is 100. You follow that? And then 8 times 25 is 200. See, there's no thinking to do. There's no mental math because I'm just doubling. You follow that? And then 16 times 25 is 400. You know, double 25, 50, 100, 200, 400. Now, all I need to do is figure out how to get 15 out of these numbers. Well, 16's no good. So I use, what, 8? And 4 would be what? 12? And 13, 14, and 1 more would be 15. Now you see how 8 and 4 and 2 and 1 add up to 15? So I just add these numbers. And that's the answer. 200, 375. 375 is 15 times 25. Is that what your calculator says? When you work it? Or did I make a mistake somewhere? And the reason you want to have this process down is because when it comes test time over this chapter, they're not going to necessarily ask you for the answer. They're going to ask you to identify one of the steps or something like that. Number 20 says, where'd it go? 21 times 63. So this one is 21 times 63. So I go 1 times 63, 63, 2 times 63, double that, 126. 4 times 63, double that, 252. 8 times 63, double this, 504. 16 times 63, double this, 1008. So you see where I make my chart? Then I'm looking for 21. So I go 16, 16 and 8 would be 24. That's too much. So I go 16 and 4 would be 20, and one more. So what do I add together? This one, and this one. So I have 1,008 plus 252 plus 63. And that comes out to be 1,323. Is that what you get when you punch in your calculator? 21 times 63? Yes?
So do you multiply by the bigger number? Like with the little table thingy, the 1 times 63?
Yeah, or actually, you know, it doesn't matter. In other words, I could have said 63 times 21. I would get the same answer. Then I would just have 1 times 21, 2 times 21. Generally, it doesn't matter which order you do it in. Yes?
How do you decide which number you're going up to?
Which ones I'm going to add?
No, like on like 17, you only go up to 8. But on 19, you go up to 16. Like, how do you decide that?
On 17, let's move over here. On 17, what does 17 say? 15
times 40.
times 40. So we start out with what? 1 times 40?
Yeah.
And then 2 times 40? And then what?
4 times 40.
Then 4 times 40? And then what?
8 times 40.
8 times 40? Good. And then what? 16 times 40. Now, as soon as I do that, see what happened? I'm not going to need 16 times 40 because 15 is the number I'm looking for.
Okay.
So now, how do I get 15?
1,
8
2, 40.
and 4 and 2 and 1. Right? And then I add all those answers together. So then you come over here and fill this chart out. And then you add those answers together. Does that answer your question? All right. So where are we now? Number 22. Okay, does everyone understand how to do Egyptian successive duplication to find a product? Okay, because now I'm going to teach you another way that the Egyptians do multiplication. And it's called mediation and duplation. 22. Mediation and duplation. That's what this is called. And what's problem 22 say? 15 times 32. Do you see how I've got it written on here? 15 times 32. Mediate means you take half of that. What's 15? Mediate would be divided by 2. So mediate is divide by 2. What's half of 15? 7.5. But Egyptians don't mess with half. They just put down 7. What's half of 7? 3. What's 7? So 7 divided by 2 is 3. 3 divided by 2 is 1. That's the mediation part. Over here, so I've got 15, 7, 3, and 1. Now let's do the duplation part. Doubling. I have 32. I go to what? 64, 128, and 256. You got it?
What's the point of that?
That's-
What does that do?
Here's the point of doing this. I'm doing Egyptian multiplication using mediation and duplation, the mediation and duplation method. And see, if you were all Egyptians, you would say, hey, that's just the way we do it in Egypt. I mean, when you learn how to do multiplication here in America, and you learned it with the Hindu Arabic system that we use, didn't you learn that sometimes multiplication was just repeated addition? So, and other times, they show you how to multiply, and then other times they show you how to punch buttons on a calculator. It's just a different way of doing it. So when we're finished with this mediation and duplation, I'm going to ask a question, as any good Egyptian professor would ask of his Egyptian students. Which method of multiplication do you like best? Would you rather do successive duplications, or would you rather do mediation and duplation? And then we can vote as to which one we like best. But you've learned how to do both. And guess what? On the test, they'll ask you if you know how to do both. So what you want to do is put an example of each one on your notes, so that you and then maybe go A, B, C, D, or steps 1, 2, 3, 4. Number the things you do, so you've got it clear in your head which way to do it when it comes time to take the test. So we haven't found the answer yet. So what do? See this little odd I have out here? Isn't this method kind of odd? Yes? So why don't we take the odd numbers? 1, 3, 7, and 15. The odd numbers on the left, and then that means we add up this one, this one, this one, and this one. So adding those up, we get 20. 3, 6, 8, 7, 10, 18, and 2, 3, 4. Does anyone have a calculator? Is 15 times 32 480? Is it? All right. Let's do another one. Number 24. 24 says 40 times 61. So I mediate over here. 40 divided by 2 is 20. Divided by 2 is 10. Divided by 2 is 5. Divided by 2 is 2. Divided by 2 is 1. You follow what I did to mediate? I just divide by 2. Mediate means divide by 2. Then duplation means I double it. 61 becomes 122, 244, 488, 976, and 1,952. Make sure you're doubling right when you do it. Now, what is it we do? We do the odd stuff. Here's odd. Here's odd. Is that it? 2, 10, 20, and 40 are even. Agreed? So I only use the odd ones. So I add together 488 and 1,952. And I get 2,440. Is that 40 times 61? Is it? Your calculator? 40 times 61 is 2,440?
Yeah.
You go, I can't believe I got that by only using 2 of them. Yeah, I know. It doesn't seem right. It's Egyptian multiplication with mediation and duplation. So you mediate, you duplate, and then you pick the odd ones on the left side. You got that process down?
So you only add the numbers that are like right beside the...
Right beside the odd mediators, the odd mediations. So now I ask the question, which do you like best? Successive duplication or mediation and duplation? You go, there should be a third choice. Neither. A, B, C. What's your preferred answer? A, I like successive duplication. B, I like mediation and duplation. C, I like neither one. On a count of 3, give me a letter. 1, 2, 3.
C.
Oh, the Egyptians would not let you past go talking like that about their numeration system.
The Egyptians.
Well, let's leave Egypt. Let's go to Babylon. Babylonian notation. There it is. 1, 10, 60, and 3600. You go, what? I'm just telling you. The Babylonians? Okay, what's the base system we use for our numeration system? Base 10. Like the ones place, then we have the tens place, then we have the hundreds place, right? And then we have the thousands place, and then the 10,000s. Multiples of 10. Well, Babylonians, and I understand, a nurse told me this one time, if you have a perfect heartbeat, your heart beats 60 beats per minute. That's the same thing we use in our clock. Maybe that's where the first clocks came from, is the 60 seconds in a minute, because that's how long your heart beats when a minute has transpired. But they didn't have minute hands back then, so how in the world did they figure that out? I don't know, they must have just listened to their heartbeat and said that sounds like a good base for our enumeration system. So we have a 1, a 10, and a 60. And after 60, it goes to 3600. So let's do 24, problem 26. Let's do 24 in Babylonian notation. So we have 2 10s to make the 20, and then 4 1s. Everybody follow that? And how do you make 10? What does that look like? One of those, what are those things called that they fly out of Whitman, whatever it is, those bombers?
B4 bombers.
Is that
B2 bombers.
those things that fly over your house and you can't even hear them? Isn't that what that looks like? Those Babylonians were drawing pictures of bombers before we even came along and figured it out. And that other one looks like an axe head or something. So we go 10, 20, and 4 of those axe heads. So look at problem 28. Now we're doing 64. 64. Okay, so 64 would be a 60 and 4 1s. Everybody follow that? How do I make a 60? You go, 60 looks a lot like a 1. Yeah, it does. But watch this. This is 60, and then this is 1, 2, 3, 4. Why is this 60 and this is 1, 1, 1, 1? Any idea why? See this empty space in here? See that empty space? I moved over to the next place value. And I will tell you that when the Babylonians looked at this number, that empty place just jumped off the page right at them. With us and the way we've been trained to think with mathematical symbols, we often don't see that empty space. So what I've done in my book is on problems 35 through 40, I've actually taken a pencil and I've drawn a little circle in every problem where there's a big open space like that. Because I know my mind isn't programmed to see it. So I draw a circle in the empty space so I know I'm moving over a place value. But let's finish number 30. What does number 30 say? 144. So what's 144? That would be 60 twice. 2 60s, that would be 120, wouldn't it? And that would leave me with 24. So I need 2 60s right here. 60 and 60. Why are those 60s? Because of this big open space here. Everybody follow that? 60 and 60 makes 120. So now I just need 24 for the rest of it. 10, 10, and 4 1s.
Wait, why don't the 60s have space in between them? What makes that not 2 1s?
What makes that not what?
2 1s.
Oh, 160? Okay, this is a 1 and this is a 1, but it's in the 60s place.
Okay.
So that's 160. and another 60, and that adds up to what? 120. And why does this little axe head equal 60 here and only 1 over here? Because of this empty space.
Okay, so you have to write it in bigger.
That's right. So you're kind of looking right to left and going, there's an empty space there, so I move over to the next place value. Yes?
Question, on the chart itself, the 60 is actually drawn bigger and longer than the 1. So do you need the space? Or if you draw it like bigger, then you would know?
If you go look at some Babylonian hieroglyphics, they will be written the same size.
Oh, okay.
And I know that they do, back on that page, they show it written bigger, but it's not written bigger in the problems.
Okay.
So whoever made the chart was probably living inside the box, like we think mathematically, and they go, you can't use the same symbol for 60 and for 1, but you can. So it doesn't have to be bigger.
Okay.
Number 34. Where'd it go? 3,883. Okay. So now we come back up here. After 60, see, this is 60. This is the 60 place. Then this is 60 times 60. What's 60 times 60? 3,600. So this place here is 3,600. So this is 1, but it's 1 what? It's 1 3,600. Because of this empty place here and this one here. See, this is the 60s place. This is the 3,600s place. You don't like this system. Doesn't make any sense. But the Babylonians built those pyramids, so they must have had something going for them. So I subtract 3,600 from 3,883, and I get 283. So what do I need? 283 divided by the next place, 60. I get 4 60s, 240, and 43 left over. So I need 4 60s. Everybody see that? I need 4 60s. So I've got 1 3,600, empty space, 4 60s, empty space, and then 10, and 10, whoops, 10, and 10, and 10, and 10, and 1 and 1 and 1, 43. And that's 43. So when you look at a number, you say, can I divide that number by 3,600? If I can't, can I divide that number by 60? And then however many times I divide it by 60, I have 4 of those, and then I have to take the rest of it, the 43, the remainder, and write it in Babylonian notation. Yes?
On page 184, there's a symbol for 600.
Yeah,
Are we going to use that?
we're not going to use that.
Okay.
Thank you for asking. They give you all that stuff that just messes with your head. We're not even going to use that one. Number 36. Now, does everyone see the little circle in number 36 right there? That empty space? So I have, what is this? This is 10, and this is 1, and 1 and 1. So that would be what? 13 times what? This is the 60s place. Remember that with that 0 there? This is the 60. So 13 times 60. What's 13 times 60? You don't know? Punch it in your calculator. What's 13 times 60? 780. Okay? Then I add 12, so the answer is 792. Everybody follow that?
Dr. Brian,
Yes.
I'm super lost on where you got the 60 from.
Where did I get the 60?
Yeah.
See this little empty space here? That little empty space says this is the ones place. This is the 60s place because of that space holder.
Where did the 13 come from?
Where does the 13 come from? This little widget is 10, right? This is 1 and 1 and 1, so that's 10, 11, 12, that's 13. 13 what? 13 60s. And that comes out to be 780. Did that answer your question? Good. Good. We're on our way. You go, man, I just finished a chapter on logic and now he's throwing Egypt and Babylon at me. Class just goes from bad to worse. But this is just really making notes as to how this process works so you can do it when it comes test time. Number 40. Now, see, 40 has empty space here, empty space here. So this is the ones place. If you're using your old stuff about ones, this is the 60s place. And this is the 3600s place. And I have 1, 1, so I have 2 3600s. That would be 7200. And then I have 10 and 1. That would be 11 60s. So what would that be? 660? And then I have 4 ones and 4. So the answer is 4, 6, 8, 8. 8,864. Well, that's enough of that stuff. Oh no. They want you to add. They want you to translate those things into Babylonian and then add them together. Like we did before. I'll let you work at that on your own because we need to cover Roman numerals. And if you get stumped on 41 and 43, then just stay after class on Wednesday and I'll show you how to do it. Or stay after class today. Well, today I want to give people a chance to correct their test. That's why I put your test up here on the table. If you want to correct it, just pick it up and have a seat and we'll walk through it. And if you don't finish it today, then you turn it back into me. If you finish it today, you give it back and I regrade it. If you don't finish it today, you give it back and say you want to work on it again on Wednesday. If you've got something going on today, this is Wednesday. On Friday, if you've got something going on today, you can wait and work on it on Friday. If you have something going on Friday, you can do it on Monday. After class, I'll be here to help people figure this stuff out. Let's do some Roman numerals. You go, oh, I'm okay with Roman numerals. I know that already. Okay, let's check it out and see. You know your Roman numerals, right? 1, 5, 10, 50, 100, 500, and 1,000. Do you have all those memorized? If you don't have them memorized, what should you do? Put them in your notes. Put those in your notes. And then you should put one more thing in your notes. Li. What's L? 50. What's I? 1. So that's 51, but when there's a line over it, what does that mean? That means 51 times 1,000. So this right here in Roman that's the Roman numeral for 51,000. Did you know that? That might be part of the Roman numeration system that you weren't taught. So put that in your notes. Which means another example, I have 10, Isn't that x is 10? So I have 10, 10, 10, 1, 1, 1. 10, 20, 33. So I have 33, but what's that line mean? Times 1,000. So I have 33,000 plus 5, 6, 7, 8. So that equals 33,008. All right? Everybody follow how that works? Good. Let's do another one. No, let's work a problem. What's the problems for Roman numerals? 45 to 50. What do they want you to do? 46. Write each number in decimal notation. Okay. What's D? You go, I don't know. What's D? 500. What's C? What? 100. You have that down in your notes yet? What's X? 10. What's V? And 1 and 1. Everybody follow that? So what does that add up to? 500, 600, and 17. There you go. Number 48. 10, 10, 10. But it has a line over it, so what does that become? 30, what? 30,000. Everybody follow that? Then, what's after X? D. What's D? 500. What's C? 100. And what's I? So 30,000. So 30,000, maybe put it up here. 30,000 what? 601. Let's do number 50. L, what's L? What's D? So what do I have here when I have 50 in front of 500? You remember what happens in Roman numerals when you have the smaller one in front of the larger one? You don't. Well, it means you subtract 50 from 500. So this is really 450, and with the bar, times 1,000. Okay? And you always treat the stuff with a bar as like a separate number. Then you come over here and look at, here's D is 500 and C is 100. So that would be 450,000, 450,000, and then what? 600. 450,000 and 600. Number 52. Now they want me to take 600, 30, and 1 and turn them into Roman numerals. How would I say 600 in Roman numerals? D, C. Everybody follow that? 500 plus 100. How would I say 30 in Roman numerals? 3 X's. And how would I say 1? 1. You got it? So what about 1,709? There's 1,000. M. 1,000 is M. Then I have 709. How do I say 700? 500 and what? 2 C's, 200s, and then 9 would be what?
It'd be 1 before the X.
Now, you say 9, that would be 1x. Say, couldn't it also be xv? No, couldn't it also be VIII? But see, a Roman would look at that and say, no, that's too many I's. This is the way to write it. So you won't see it written like this because that's poor Roman mathematician. That's poor Roman math. So you have to make a judgment call as to when you say, if I get all those I's out there and say, no, I put IX, that looks cuter. Let's see. Is that enough of that? Yeah, we better move down to. Write each number in Roman. Oh, is that what we were doing?
Yes.
56? We better do 56 then. 49,000. How do you say 49,000? How do you say 49? What's 50?
1X.
Is 50 L? How would I say 49? Put a 1 in front of it, right? And then since it's 1,000, I would put a line over the top of it. Everybody follow that? So 49,200, how would we say 200? C, C, and 31. 10, 20, 31. You feel powerful? Stop when you get to 55. That's enough of this stuff. So now you know how to do Egyptian numeration, Babylonian numeration, and Roman numeration. Don't you feel powerful learning all of these foreign mathematical languages? If I would have said, I'm going to come here today and teach you some Russian, some German, and some Swahili, you would have said, wow, that's cool. And I'd teach you how to say hello and goodbye and order something at McDonald's and all of those places. But I expand your mathematics repertoire and you go, bleh. All I can say is, have a good day. I don't take offense.